Okay guys, today we're going to deal with function composition. Okay guys, so here's a definition. Function composition is written like this, and we read it as f of g of x or f composed with g. We can also write it as f and then with the g of x on the inside. So remember when we had like f plus g of x yesterday? We could rewrite that, and we actually encourage you to rewrite that as f of x plus g of x. So the same thing with this is we'll see it like this sometimes, but it actually helps out to write it like this. Now, also another thing to be careful of, this is not a multiplication sign, it is an open dot. So that's how we know what its composition is, because it has that open dot there. Okay, all that this means is we're going to take g of x and substitute it in or put it in for f of x. So essentially we're just going to substitute g of x into f of x. So essentially, composition is like substitution. So this first example, it gives us two functions, f of x and a g of x. So what we're going to do is, first thing I always do is I rewrite this. This is f of g of x. Okay, so whatever one is closest to the x is the one that goes in the first parenthesis, and then f goes on the outside. So what that means is we're going to take this g, so we know g of x, and we're going to take this and plug it in to our f function. Okay, so I'm going to have my f function is 2, and now I'm going to plug in this g function. I'm going to kind of use a different color to kind of show you. Our g is this guy, so we're going to take in and plug it into our f. So we're going to plug in x squared plus 3x plus 5 into that spot where the x was on the f of x. And then we're just going to go ahead and bring down that minus 1. Okay, so we just took the g and we substituted it in for the x of the other function. Okay, now we're just going to go ahead and clean this up. We're going to distribute. So we'll have 2x squared plus 6x plus 10. And then just bring down that minus 1. Then we'll go ahead and combine like terms. So 2x squared plus 6x plus 9. And that is our final answer. So let's look at another example. Now this is very similar to the last one, except this is, if you notice, this is g of f of x. So we're going to have our g is first, and then we're going to put f of x inside of the parentheses. Okay, and then this tells us that we're going to take f of x and plug it into the g function. So we're going to take this, I'll go ahead and write it in blue. So this, or red I mean, we're going to take this f of x, and we're going to plug it in anywhere that we see an x in the other function. Okay, so we're going to have, our first one is, so we're going to have something squared plus 3 times something plus 5. And I'm just going to go ahead and fill in those parentheses now with the f function. So I'm going to have 2x minus 1 and then 2x minus 1. So I just plugged in the x's with the f function. Okay, so now when we're doing this one, remember 2x minus 1 squared is 2x minus 1 times 2x minus 1. Okay, so let's multiply this out. That would be 4x squared minus 2x plus 1 when I distribute that out. Then I'll have to distribute this, so that would be plus 6x minus 3, and then just bring down that plus 5. Now once I have that, I'm going to go ahead and combine my like terms. So I have this 4x squared. Okay, I have a negative 2x, and a positive 6x. Well, that ends up being negative 4x plus 6x, which is positive 2x. And then I have this plus 1, and I have this minus 3, and this plus 5 that are all like terms. So I'm going to go ahead and combine those. I just highlighted them to show that they're all like terms. So 1 minus 3 is negative 2, plus 5 is going to be a positive 3. Okay, so this will be our final answer. Okay, this last example, once again, I'm going to go ahead and rewrite this. Okay, so we're going to go ahead and put this as k of h of x. So that tells me that I'm going to take my h, or that first one, and plug it into the other. So I'm going to take h and plug it into the x's on the other one. So that means I'm going to have 4. And then instead of x, I'm going to put in that 10 minus x plus 7. Okay, then we'll go ahead and distribute. So this is 40 minus 4x plus 7. Then combine like terms, well, that's just negative 4x plus 47. And that is my final answer. Now, we talked about this yesterday in notes when we had like a number. So when we have to evaluate a function, so plugging a number in there. So like, there's 2 ways we can do it. We can do what we just did and then substitute it in at the end. Or we can just do the first function and then substitute it into the second function. I like to do option 2, and that's the way that I'm going to be working these ones out. So looking at those last functions, okay, we have f of negative 2, and then k is on the outside. So if I kind of cover up the k, and I just focus about this f of negative 2. Now looking back at that earlier in the notes, our f function is 2x minus 1. That was what f of x was. Okay, so I'm going to go ahead and just do that f function, but instead of x, I'm going to plug in that negative 2. So negative 2 times negative 2 is negative 4, minus 1 is negative 5. Okay, now once I have that part done, I'm going to go ahead and use that and bring my k down and do k of negative 5. Now looking up, our k of x was 4x plus 7. Okay, so now I'm going to use k of negative 5. So I'm going to plug negative 5 in for my x in the k function. So this is going to be 4 times negative 5 plus 7. Okay, so that'll be negative 20 plus 7, which gives me negative 13. And that is our final answer. So for this one, the first thing I would do is I said, let's go ahead and rewrite this. This is going to be h of g of 5. Okay, so that tells me I'm going to do the g of 5 first. Well, let's refresh ourselves. The g of x was x squared plus, I think it's 3x plus 5. So we're going to go ahead and do g of 5. So we're just going to plug 5 in for our x's. So 5 squared plus 3 times 5. Then just bring down that plus 5. So I just subbed in those 5s for the x's. So 5 squared is 25 plus 15. And make sure you do your order of operations for these. 25 plus 15 is going to be 40. 40 plus 5 is 45. Okay. So now I know what g of 5 is. So now I'm going to do, essentially we're going to bring down this h. So we're going to now do h of 45. So remember our h of x was 10 minus x. So we're going to do h of 45 would be 10 minus, and then for x we plug in 45. So 10 minus 45 is going to give us a negative 35. That is our final answer, is that final one. Be careful. Some people want to stop at that 45, but you got to take that answer and plug it into your next one. So this right here is our final answer, that negative 35. Okay, the thing with compositions is we use them in real lives. So here's an example. You have a coupon for $25 off your bill, and you also have a 10% off coupon. Okay, so if we look at this next one, it wants us to write a function f of x for our cost of bill after using the coupon for $25 off. So first thing we need to write f of x equals, okay, we don't know how much our bill costs, so we'll call that x, and we're just going to take away $25. So we're going to take away just 25. This is similar to what we did our very first unit. Now write a function of g of x for a cost of our bill if we use the 10% off coupon. So it's going to be g of x equals, now think, if the bill is 100% and I'm taking away 10%, I'm only going to be using 90%. So this is 0.9 of x, or of our bill. Okay. Now it wants us to find f of g of x. So if I did f of g, so that would be f of g of x. I would take my g function, which our g function was 0.9x, and we're going to plug it into the f function. So this would be 0.9x in parentheses, and then minus that $25 off. Okay, so which one did I do first? I did the g of x first, so that means we would do the 10% coupon first. Okay, now if I did f of g, that would be, or g of f, I mean, we would have that. Well, our f is at x minus 20, so that's the one that we're going to use first. So we have x minus 25 in parentheses, and then we're going to have our 0.9 that's out front, because we're taking our f and plugging it into g. Okay, we can leave it like that, but this would just be if we did the $25 off first. Now, which one of these saves us more money? The easiest way to find it is, let's just pick a number that we're going to say how much our bill was. So let's pick a nice one. Let's just pick 100. Okay, so let's do the top one first. Okay, I'm going to do C first. So that's going to be 0.9 times 100. Okay, we're going to do that first and then subtract 25. Well, that's 90 minus 25, which is going to be 65. Okay, now let's do D first, or D next. Okay, we're going to do our 0.9, and then let's say our bill was $100 minus 25. That ends up being 0.9 times 75, which is 67.5. Okay, so which one's going to save us more money? We're either going to spend $65 or $67.50. I would rather do the first option, which is going to be the one that is 10% first. Now go ahead and try your X ticket. X ticket is just how would we describe composition or function composition in a complete sentence. My sentence would probably be something along the lines of that function composition is substituting one function in for another. Go ahead and finish this and then get started on the practice problems.